Hello guys, today we are going to be looking at Boolean Algebra. And in Boolean Algebra, there are some steps which you should follow. There is a state which is A. A represents the first state, and the A bar, if you see A bar, this one represents the second, this one first state, and this one here A bar, which is second state. And this one A bar, it means that it is not A. That's what it means, A bar. So now let's try to look into some of the function used in Boolean algebra. So now let's start with the number one. We are going to start with the O function. For you to show this O function in a circuit diagram, it is written as in a circuit diagram. It is shown as this O function means that when you cross this first circuit, it means that when you cross this circuit here, that means a bulb will be on. When you cross B also, the bulb will be on. When you cross all the circuit, the bulb will be on. But when all the circuit is open, the bulb won't be open. So now let's try to draw the truth table for this OR gate or function. This is O function. So let's try to draw truth table. The truth table will be then here we are going to have two terms, which is A and B, which is A here B. So we cross here. This circuit which you are seeing here, when it is not crossed here and here, that means when here it is not crossed and here, that means our output, when you add, we are going to say Z equals A plus B. When you add A plus B, because when you didn't cross this circuit for A and B, that means we have 0 here and here 0, which means the output it will be 0. What if we cross this A which we have here? We cross this one here. That means when you cross A here, that means when you cross here, the bulb will be on, because this is a connection here, so in which we are going to have 1 here. What if we cross A and we leave B? We didn't cross B here, we cross A. So that means whenever you cross one of the circuit, the bulb will be on. That means our output it will be 1 here. Then here, whenever you cross this input switch, when you cross A and B, when you cross A here and B, that means the switch will be on, so the output it will be 1 here, because when you add A plus B, 1 plus 1, in Boolean expression, 1 plus 1 it is equals to 1, it is not 2, because this switch, when it is closed here 1 plus 1, that means the whole system it will be 1. It is not equals to 2. Don't make that mistake. So in AND gate, when you close this switch A here, the bulb won't be on, because this switch it is still open. So in AND gate, the truth table, it is drawn as the truth this one in AND gate, it is presented by A multiplied by B. In OR gate, it is plus, but in AND gate, in AND function, it is multiplication. So now let's try to see if you close this switch here for A1, then B is open. That means the bulb won't be on. When you leave all the switch to be open, the answer here 0 times 0 when you say A times B, so 0 times 0, which is 0 here. What if we say we leave A and we close B? When you close B here, that means the switch is still open, so the bulb won't be on. So that means our output here, when you say 0 times 1, it is 0. 0 times 1 here, it is 0. Then what if we say we close A and we leave B? Also means the same. The answer, it will be 0, because 1 times 0, it will be 0. Then when we say 1, when we close 1 here and B 1 here, then the bulb will be on because all the switch, it is closed. So the output, it will be 1 here, because when you multiply 1 times 1, it will be 1. So we end here. Then we only deal with zeros and ones. So that's why I was putting 0 and 1 here. Thank you for watching, and don't forget to subscribe and turn on the notification bell so the next time you see the new update.